So a couple more on P5 day 2. On this first one, number 100, I'm going to take out an x squared plus 3. And to what power? The lower of the two, which is negative 5/3. And then I have to see what's left of each piece. When I divide away an x squared plus 3 to the negative 5/3 power, and I do that division, I have to keep the same base and subtract the exponents. Negative 2/3 minus negative 5/3 is negative 2/3 plus 5/3 is 3/3 is to the first power. And then this divided by x squared plus 3 to the negative 5/3, anything divided by itself is plus 1. So when I'm cleaning this up, this is going to become x squared plus 4, and this is going to move to the denominator as x squared plus 3 to the positive 5/3. On 104, oops, I have my paper here, sorry. On 104, it's a trinomial, each of which has an x minus 1 term. So I'm going to take that x minus 1 out in front, and I'm left with 12x squared here, minus 4x here, and minus 5 here when I divide out that x minus 1. Now this remaining piece has to be factored. A lot of options for 12. I don't like that, so I'm just going to split the middle term and look for two numbers that multiply to get negative 60 that will combine to get negative 4. 160, 230, 320, 415, 512. I'm looking for a difference of 4, 6, and 10. So specifically negative 10 and 6. 12x squared minus 10x plus 6x minus 5. Split that up, factor out a 2x, left with 6x minus 5. Take out a positive 1 when all else fails, 6x minus 5. So that is one of the terms, and 2x plus 1 is the other. And then, of course, don't forget about your initial factor that you took out of the whole thing. 106 is just a typical either split up the x squared term in the middle, two numbers that multiply to get negative 35 and add to get 34, or just guess and check. And I think this one, because 7x to the 4th has to be 7x squared and x squared. And then 5 has to be 5 and 1. It's either 1 and 5 or 5 and 1. I like the 5 here because that makes 35, and the 1 here. And I want it to be a positive 35 minus a 1 to make 34, and so that's that. Now in the Slater, I know it does this difference of perfect squares and it splits up into root 7x. This is not a perfect square. This is my final answer. And then the last one, we do have x plus y to the 4th and x plus y to the 2nd, so we do have an x plus y to the 2nd overlap. So I'm going to take out x plus y to the 2nd, and I'm left with x plus y to the 2nd here. Divide out two of them, I'm left with x plus y to the 2nd minus 100, because that one's gone. And then this is the difference of a perfect square and a perfect square. So this is going to factor into conjugates. X plus y plus 10, x plus y minus 10, and then the x plus y squared out in front. So I hope that helps.